How do stars form and die?
Stars are the cosmic engines of the universe, responsible for the creation of elements that make up everything around us. They are more than just points of light in the sky. Without stars, there would be no planets, no life, no elements like carbon, oxygen, or iron. These celestial giants have shaped galaxies, forged the elements that make up life, and illuminated the cosmos for billions of years.
But how exactly do these incredible objects come into existence? And what happens when their brilliant lifespans come to an end? The birth of a star.
Stars are born in regions of space known as nebulae, which are vast clouds of gas and dust. These regions are often referred to as the nurseries of the universe. Nebulae are mostly composed of hydrogen, the simplest and most abundant element in the universe. Over millions or even billions of years, gravity begins to take hold within these clouds. Slowly but surely, particles of gas and dust are pulled together, creating a denser and denser core. This gravitational collapse isn't a smooth process. As the gas compresses, it begins to heat up, and the core grows hotter and more compact. At a certain point, when the core temperature reaches approximately 10 million degrees Celsius, a remarkable event occurs. Nuclear fusion begins. In this process, hydrogen atoms fuse together to form helium, releasing an enormous amount of energy in the form of light and heat. This is the moment the star is truly born. It's not a quick process. This can take tens of billions of years, but when the fusion ignites, the star begins its long life of burning brightly in the cosmos. Stars form in different sizes, and the size of a star at birth will dictate much of its future. Some stars are small and dim, while others are enormous and incredibly bright. For example, red dwarfs, the smallest stars, are the most common in the universe. They can burn for trillions of years, outliving even the largest galaxies. In contrast, blue giants, some of the largest stars, live fast and die young, burning through their fuel in just a few million years.
Life cycle of a star.
The life of a star is one of balance. A delicate equilibrium exists between the outward pressure from nuclear fusion in the star's core and the inward pull of gravity trying to collapse the star. This balance keeps a star stable for most of its life. As long as the star can continue to fuse hydrogen into helium, it remains in this stable phase, known as the main sequence. Stars like our sun spend the vast majority of their lives in this phase, fusing hydrogen into helium. For a star the size of the sun, this phase lasts about 10 billion years. But stars come in many different sizes. Smaller stars have much longer lifespans because they burn through their fuel at a slower rate. Larger stars, on the other hand, are like cosmic supercars. They burn brightly and quickly, consuming their fuel in a relatively short amount of time. As stars age, the hydrogen in their cores begins to run out. When this happens, the star must find new elements to fuse in order to continue shining. Larger stars have enough mass to begin fusing heavier elements like helium, carbon, and even oxygen. As the core contracts and heats up further, these heavier elements fuse together, providing the star with more energy, at least for a while. Eventually, however, every star must face the inevitable. It will run out of fuel.
Death of a star, supernovae and black holes.
When a star exhausts its nuclear fuel, the end of its life depends largely on its mass. Smaller stars like red dwarfs end their lives relatively quietly. After they exhaust their fuel, they slowly shed their outer layers and leave behind a dense core known as a white dwarf. These white dwarfs will continue to cool and fade over billions of years, eventually becoming so dim that they're virtually undetectable. For larger stars, however, the end is far more dramatic. When these massive stars run out of fuel, the core contracts and heats up to unimaginable temperatures. But without enough energy from fusion to hold off the force of gravity, the star collapses. This collapse results in a supernova, one of the most violent and spectacular events in the universe. In a fraction of a second, the star's outer layers are blown into space in a cataclysmic explosion, outshining entire galaxies for a brief period. After the explosion, what remains of the star's core depends on its original mass. If the star was particularly massive, the core can collapse further into a neutron star, a dense object about the size of a city, yet with more mass than the sun. Neutron stars are so dense that a single teaspoon of neutron star material would weigh billions of tons. If the star was even more massive, the core's collapse doesn't stop there. The core continues to collapse under its own gravity eventually forming a black hole, a point in space where gravity is so strong that not even light can escape. Black holes remain one of the most mysterious and fascinating phenomena in the universe, and their existence poses questions that science is still striving to answer.
Cosmic recycling, stardust, and new life.
When a star dies, it doesn't just vanish. In fact, the death of a star plays a crucial role in the life cycle of the universe. The material that is ejected during a supernova or in the final phases of a star's life becomes the raw material for the next generation of stars and planets. This process is sometimes called cosmic recycling. The elements created inside stars like carbon, oxygen, and iron are spread throughout the universe when a star dies. These elements become part of nebulae, where new stars are born. In a very real sense, everything we see, touch, and even breathe was forged in the heart of a star that lived and died billions of years ago. As the famous astronomer Carl Sagan once said, "We are made of stardust." This process of star formation, death, and rebirth is the engine that drives the universe forward. It's a cycle that has been going on for over 13 billion years and will continue for billions more. Every time we look up at the night sky, we're witnessing the past, present, and future of the universe unfolding before us. Stars shape the universe and everything in it, including us. Their formation, life, and death are part of a cosmic dance that has been ongoing for billions of years. Without stars, there would be no life, no planets, and no galaxies. The more we learn about these celestial giants, the more we realize how deeply connected we are to the universe.
What fascinates you most about stars? Is it their birth, their fiery lives, or their spectacular deaths? Let us know in the comments below. And don't forget to subscribe for more cosmic discoveries. Join us on this journey through the stars with the AI Explorer. Until next time, keep wondering and keep exploring.